Hello and welcome to my presentation about epoxy. So, what is epoxy resin? Epoxies are thermoset plastics made by the reaction of two or more industrial chemical compounds. They are widely used in both consumer and industrial settings because of their toughness, strong adhesion, and chemical resistance. You may have used it before. It's a pretty common alternative to superglue. As you can see in the bottom right corner, this is what it may look like. It is stored in two separate containers because once you mix the two compounds, it will start to harden and start that thermoset reaction. Some examples of industrial use are epoxy for coating floors and epoxy for laminating countertops. Basically, anything with a sealant, paint, anything weatherproofed has one of the epoxies in it. There are multiple epoxides. Um, Epoxy is just well known for being very weatherproof, very chemical resistant. Overall, it has a high longevity, which makes it very popular for use in construction projects and all of that. So the social/economic value of epoxy. Epoxy resins are used in a lot of construction projects and is basically used in any adhesive plastic paint, coatings, primers, sealers, flooring, and other construction materials. It's essentially a plastic that can be used to weatherproof things and make them last a long time, which reduces waste of society and turnover rate of materials, so it makes things last a lot longer. Economic wise, epoxy resin it makes up a very large market, a large portion of the market of sealants and adhesives, and is becoming more popular in the art world as a medium. There's a difference between resins and epoxy resin, but epoxy resin is well known for being a lot longer lasting and more expensive, so it's mostly used by the professional artists. As for the chemical reaction, epoxy resins are reacted by the combination of a polyepoxide, which there are multiple types, and either another polyepoxide or a wide range of co-reactants, otherwise known as hardeners. So this is what the two tubes are. One tube will hold a polyepoxide and the other will hold a hardener. And the combination of these two will start to cure the polyepoxide into a hard substance known as a thermosetting polymer. So basically the equation is polyepoxide plus hardener equals thermosetting polymer. As shown on the right, there is an intermediate product in the middle. This specific reaction is that of bisphenol A diglycidyl ether, which is the final product. It's a very popular, it's probably the most produced epoxy polymer that there is. And it's produced with the combination of epichlorohydrin and bisphenol A. The intermediate is bisepoxide, and it's quickly phased out with the presence of sodium hydroxide. And then the chemical reaction between epoxides and hardeners as the epoxy cures is exothermic. It generates heat. So that means the enthalpy is going to be negative in this reaction because it's exothermic, it is losing energy. And the entropy is going to be positive because exothermic reactions lead to increased disorder due to the faster moving particles. And the exothermic characteristic creates a positive feedback loop. So basically, the reason it's called a thermosetting polymer is because the reaction produces heat, and the characteristics of the epoxy trap the heat, which causes it to generate even more heat and more until it eventually sets itself rapidly, actually, by thermosetting. So the more heat there is, the faster it will set, and the faster it sets, the more heat it produces. So that's what creates the positive feedback loop, and that's why it's called a thermosetting polymer. So this would be the industrial production of this polymer. So this one is also this diagram is showing the similar production of, again, diglycidyl ether of bisphenol A. So this is what's being synthesized, and this is the industry-specific qualifications. So basically, epichlorohydrin is reacted with bisphenol A, and water, sodium hydroxide, and it is reacted at 70 to 80 degrees Celsius, which forms DGEBA, which is the shorter version of diglycidyl ether of bisphenol A. which is one of the most commonly synthesized epoxides. Now, in the synthesis, there are some additional factors. Of course, environmental impact. Epoxies are very long lasting, which means that they are non biodegradable and they are resilient to weather conditions, giving them around the same environmental impact as plastics, as in they take a very long time to decompose. There is research being done to create bioepoxies that can biodegrade faster than normal epoxies so that they aren't so long lasting and taking up a lot of space on Earth, and aren't as harmful for the environment. As for safety, within factories synthesizing this product, many commercial hardeners are hazardous upon contact or inhalation, so workers synthesizing these materials generally wear protective gear at all times. And for quality control, factors that are monitored include chlorine content, viscosity, and softening point for these epoxies. And these are the references. Thank you and have a good day.